Hello, I'm going to go over some help for the exam part 2 of our class, where we're going to use R to answer some questions. So everybody has a file. Now, depending on your last name, you get a different file, different data, and different questions. So you pick the correct data file that goes with, and it goes with the first letter of your last name, your surname. I picked one of the files. It doesn't matter. Each of the files have the same example, and this example you can use as a blueprint for all three problems that you have. So the first thing I want you to note is I say you can upload the file using the Import Data tab. That's how I like doing it. It's nice and easy. But if you have any trouble doing that, here's the code to read in your data. Okay? Now you'll have to find your particular pathway, but I would say if it works for you, just use your RStudio and import your data. So you would go here, you want to import a data set, and our files are Excel files, and this brings you right to it. So I found my file, I imported it, and I can view it right here. And then it's right here in my global environment, the 15 observations. So now the first thing we want to do is do a data analysis of this. And in the file that I give you, I show you how to get your probability plot right here and how to get your box plot right here. You know, I give you the code for all of this. So you can copy and paste it. You can actually write it out however you want to do it. Now remember, these are how we comment in R. So those are just comments. So we're doing our data analysis. So I'm going to copy and paste that and put that in my R environment. So in here, I have to put in the correct data set. Now mine isn't called Crickets Temp. That's not the correct data name. It's Crickets. See, the data name of mine is this right here. So you have to make sure you have the right data name, Chirps. And there's the data set. It helps you along. And then I want the variable, and I'm doing it on temperature. So it leads me to the right variable right in there. So I have that, and now I'm going to do, this is the line that tells it to do a probability plot right here, and this all tells it to do a box plot right here. And you can title it, do whatever you want for the for our project. For our project in here. But as you note, I have the wrong data set once again, so I need to make sure this same data set name and the variable name is put in there. So when I hit enter, it's going to give me the box plot and the probability plot, because there were two plots, so you go to your arrows to find both ones. You're going to want to copy your code that you use, so you literally just highlight and copy it, put it into your program, and then you want to copy your graphs and put them in there. So you would export your probability plot, copy it here, copy that plot, then put it into your report, and then copy and put that into your report. You know, copy that plot and paste it into your document. And as you can see from these, there are no major deviations from normality. This is pretty linear. And my box plot, because my sample size is so small, has no outliers, so I can do my technique. Our techniques that we've learned in class for inferences, that is confidence intervals and hypothesis tests. So you would have copied your code, put your plots in there, and then basically this is what your conclusions would say. Based on the probability plot, there doesn't seem to be any deviations from normality, and since the box plot has no outliers, don't have to worry. Therefore, it's reasonable to assume that this sample came from a population that's normally distributed, and you can do your Z or T test. So the next is to do a confidence interval. Now, a confidence interval, look at what the code is. We're going to do, it's called a t-test because we don't have sigma. None of these problems have sigma. That's the point of using R. R has a built-in command for our t-test, making sure, however, that our conditions were met, which is what we just did. So I'm going to do a t-test on my data and a confidence level. So if I wanted a 99% confidence interval, I would have put not 0.9 but 0.90 but 0.99. If I wanted a 95% confidence interval, instead of the 0.9 right here, I'd put in 0.95. That's how you change for the different confidence levels to get the confidence interval that you want. So very easy code. So I put in t.test, my my data set, and then the variable that I want to do it on, I want it on temps. And now I'm ready to say what the confidence level that I want. So confidence level, and in this case I wanted a 90% confidence interval, 0.90. Hit enter and there's the information. So what I'm focusing on is not a t-test. I don't care about the test statistic or the p-value. What I care about is this part right here, the 90% confidence interval. So I want to copy all of this, put it into my Word document. So I've copied my code. Here's my output, and what we focus on is what I have highlighted right here. So when you write your conclusion, you'd say the mean temperature necessary for crickets to chirp at about 15 chirps per second is between, and you see it right here, rounding to 1 decimal place, 77.0 to 83.1 degrees Fahrenheit with a 90% confidence level. Or that's our 90% confidence interval. That's one way you can state the conclusion. Make sure you state it in the context of the problem and correctly. The second part of your problem, you'll have 3 problems. Each problem has 2 parts, getting a confidence interval and doing a hypothesis test. So the second part of a problem will be the researcher believes, some sort of hypothesis test. So this one is the researcher believes the mean temperature has changed from 76 degrees. We are now, based on what that says, in a two-tailed test. If it had said the researcher believes the temperature has increased, it would have been a right-tailed test, or has decreased would have been a left-tailed test. But this one says changed. So we're in a two-tailed test. Test his claim at a 0.05 significance level. Now we're going to do our 6-step process that we've done throughout the class. And we're going to actually use the output of R in order to say whether we reject. We're going to get that p-value. Now we already know that all the conditions were met for this data set, so we can do a hypothesis test. And of course, since we don't know what population standard deviation is, we're in a t-technique. We would have to go to the student's t-table, but lucky for us, R will do all the work for us, as it did for the confidence interval up above. So how do we do a t-test? Well, a t-test, we use our data set, the variable that we want, but we now have to let it know what the value is in the null hypothesis. We have mu is 76. So it might be advantageous for you to write your null and alternative hypothesis so that you realize what value's in the null and what your alternative is. And like we said, it was two-sided. So if you have a left-tailed test, you would use less instead of the two-sided alternative. If it was a left-tailed test, you would use less. If it were a right-tailed test, instead of the two-sided that you see here, you would have put greater, making sure that it's in quotes. So we're going to do our hypothesis test for the crickets. Once again, we're going to use the same code as you see up here, this t-test, but instead of confidence level, we're going to put in the mu, and we're going to say what type of test it is, left, right, or two-tailed, two-sided, less, or greater. And as I write it in, it gives me my file, and then the particular variable, which is temp we're doing this on. Mu is going to equal the 76 that we see in our problem, and the alternative is, for us, it's two-sided, two-dot-sided. And now I'm ready to let R do its work, and it gives me my answer. My answer is my test statistic, which is right here, and my p-value, all for me, gives me my p-value right there. So I'm ready to copy all of this and put this into my, not only the output, but also the code, and I'm ready to copy that and put it into my document. When I do, here it is, my code and my output, and now I'm ready to do this 6-step process. You are going to have to write the null and the alternative hypothesis in here. And just being exact, this would be the null hypothesis distribution, but we don't know what sigma is, so we're going to have to use the student's t-distribution when we our test statistic. When we get our test statistic, it will be in the student t-distributions. We state our significance level, get the test statistic right from our output of R, and then the p-value right from the output in R. Put that in there, and then you determine whether you would reject. Since my p-value is less than my alpha, since 0.03509 is less than my significance level of 0.05, I would reject the null hypothesis. And then it says, state your conclusion in the context of the problem. Well, then we would say at a 0.05 significance level, there's sufficient evidence to support the researcher's claim that the mean temperature it takes for crickets to chirp 15 chirps per second has changed from 76 degrees Fahrenheit. And that's the basic template for all the different problems, the 3 different problems that you have on your part 2 of your final exam using R. Thanks so much for watching.